Hello everyone, welcome to Codynamics. In this video, we are going to see how to do deep neural networks for image classification. So we are going to use Tensorflow, NumPy, Matplot library, scikit-learn and Keras to do image classification using deep neural networks. So we will be using this data which you are seeing on the screen, which is like handwritten numbers. So it is from 0 to 9 and we will be using the deep neural network to do the classification, and based on the input at the end we will be able to identify which number is what. So the input will be something like these numbers on the screen, like 5, 0, 4, and each image will come with its own label, the appropriate number, so whatever number it is, and then we will make our machine learn these numbers and it will be able to identify at the end of this tutorial. Just in case, if you want to know what exactly we are going to do, and if you are very new to deep neural networks, then I highly recommend you to watch this video from 3 Blue 1 Brown. He has amazingly explained what we are going to do now with the same data set, but in a very mathematical way and in a very ground level way. To get started with the tutorial, I have made a Jupyter notebook, and in that I have made a file called number classification, and I made this markdown file. So these are the steps that we are going to do in order to make our deep neural network model and make the predictions on the numbers. So I went on to make this import section. So these are the libraries which we will be using in this tutorial: the Tensorflow, Keras, scikit-learn, Matplot library, and NumPy. So if you have not already installed any of these, please go on and install it before you proceed with the tutorial. Now I assume that you have already installed, and let's proceed with the tutorial. Now let's load the data. So this data set which we are going to use is called the Mnist dataset. This can be imported from tf.keras.datasets.mnist. So if you want to see this, all you have to do is mnist dataset Keras, and if you go here, they have explained how to import it and all. So this is exactly what we are going to do. You can see that the shape of the X train, which is the training data set, we have 60,000 samples, and each of the image is like 28 by 28 in size, the pixel size. And for the testing, we have 10,000 samples, again the same image size. And the labels for the testing, the training, we have 60,000 because we have 60,000 images, so we need 60,000 labels. Similarly, we have 10,000 labels for the 10,000 testing images. And now we can start importing. So I personally prefer to use camel case, so I'm using it. If your preference is using with underscores, then you can surely do it. It's up to you. Mnist dot load underscore data. So this is like a keyword. The load data is a keyword. So let me just run it and I'll show you what is there. So if I print the X train, you can see this is just bunch of arrays. You can see that. So if I print X train dot shape, you can see that the shape is 60,000 by, so we have 60,000 images and we have 28 by 28. That's the image size. So if you want to see just one image, let's say the first image, then that image will be having 28 by 28 as the size. So it has 28 pixels in the x-axis and 28 pixels in the y-axis. Similarly, if you go to ytrain.shape, you'll see that it has 60,000 labels. And obviously, if you load the first label, it will be just one value, so it's not an array, you cannot get it. So if you want to see what is the first image and what is the first label, let's first see what is the first label. It says it is 5. Okay, so the first image has to be showing 5, right? So to do that, what we are going to do is plt.imshow xtrain. So we want to see the first image, so it is 0, and you have to put plot.show. So you can see that we are getting a 5. So let me put this in the same cell, and I will put a print statement to this. Okay, now I'll delete this and let me run it. Yes, we have a 5 and it says 5. So let us also see other images in the data set because we have 60,000 of them. Let me put it, say 50. Yes, the label is 3 and the image is 3. But if you have seen here, or in this, the image which I have shown, it is in black and white. So how do we actually make it black and white? So to do that, all you have to do is cmap is equal to plt dot cm dot binary, and if you run it, you will be seeing it in white and black instead of black and white, if you know what I mean. So what you have to do is put underscore r, so reverse it, and you will get this. And if these numbers are irritating, all you have to do is like access and off. Yeah, so we are able to see that the 50th data is 33, and if I put 1000, we have a 0, and if I put entirely a random number, then we are going to see this. But if I put 60,000, we are going to get an error because we have 0 to 60,000 images. So 60,000 minus 1 is the last data set. So we are able to see this. Let me put some random images, number. Yeah, we have got this. So now it's time to normalize the data. So what is normalizing? Let me explain it. If you see some value, okay, so if you see the data set of the 34th or basically the 35th image, you can see the values range from 0 to 255, that's the max, and we have 251, 253. So since this is an image, the maximum value it can have is 255. So if the value is from 0 to 255, and for the y-axis also it is from 0 to 255, then we have a larger scale on the graph. So if you imagine it as a graph, then we have the value starting from 0 to the large scale of 255. Instead, just like what we do in statistics, if we normalize the data, if we make all the data fit within 0 to 1, then the process will be much easier and the accuracy could actually improve. So how do we actually do it? So to do that, extrain by 255. If you do that, let me do it just for 1, either 20. You can see that all the values are now between 0 to 1. Nothing exceeds 1. It might be close to 1 or it is 0. It is never above 1. So that is what normalizing is. So we are going to do this for the entire data set. You have to do this when you are loading and also in the same cell, otherwise you are just going to keep on running it and it will cause issues. So we are going to do it for xtrain, and the xtest is equal to xtrain by 255, xtest by 255. There is a module in Keras to do the normalization, but it's not very good for these kind of data set. So I am not going to explain it. You can just do this and you will be fine. And you can see that we have got it. So just to visualize what is there in xtest as well. You can see that again it's bunch of numbers, and if I go to specific one like 25, you can see again it is just 0 to 1. So we can be sure that our normalization has worked. Run it once and run this once. Okay, now we are completely ready to create the deep neural networks. Before we create the deep neural network, I just want to do one small thing. If you remember, for the xtrain.shape, we had 60,000 images with 28 by 28 as the size. So we might need this 28 and 28, the x and y values, so as to flatten the image. If you remember from the video of 3 blue and brown, we have to flatten everything, then give it as the input to the neural network. So to remember what is the size of this, what I'm going to do is I'm just going to take for one image, and if I see the shape, it's going to be 28 comma 28. But since x and y are same, otherwise I would save it as x shape and y shape in a two separate variable, but here now it is the same. So what I'm going to do is just take one, which is the 28, and I'm going to save it in a name called shape. Now if I print shape, we have 28. So this is what I wanted to do before we create deep neural networks. Okay, now we can start with the creation of model. So what we are going to do is model equal to TensorFlow, that is tf dot keras dot models dot sequential. Okay, so if you want to know more about keras dot sequential, can check this, and you can see all the documentation here. So what we are going to do is just take this keras dot sequential and we are going to use it. So just before you do anything else, try to run the cell and make sure it's not giving any errors, and ensure that the S is capital if it is giving errors. Okay, then the next thing what you have to do is give input to the neural network. So that can be done by model.add tf.keras.flatten, because we are going to flatten the image. Then give the input shape, which is equal to, and put it inside parenthesis shape comma shape. Okay, it is giving me some error. Okay, keras dot layers. So since we are working with layers, we have to put the layers. Okay, now we are not getting any errors. Okay, so that's it about creating the neural network. Now that we created the model and given it the input, now let's create the hidden layers. To create the hidden layer, again we are going to add a layer, just like what we did for the input layer. We are going to add another layer. It's called tf.keras.layers.dense. So if you want to know about the dense, you can go here and you can check the documentation. So it takes a lot of inputs, but in this tutorial we are just going to stick with the units and the activation. So what we are going to do is we are going to use 128 neurons in the first layer, and for activation you're already familiar with it. For all the hidden layers, we'll be using ReLU as our activation function. So to create another layer, we are just going to do the same thing. But sometimes when we run the cells multiple times, it's going to create more and more layers, and we don't want it. So what I'm going to do is I'm going to put it here only, add hidden layers, I'll add it there. Okay, so whenever we are creating the model, it will add the layers. Now we can add the output layer. Actually, I can add it here itself. Add output layer. So again, what we are going to do is model.add tf.keras.layers.dense, and now we are going to get 10 outputs, 0 to 9. Those are the numbers we have. So I'm going to put 10 as the unit, and for activation, for the output we will not be using ReLU, never. Either we'll be using sigmoid or softmax. So sigmoid is used mostly for binary classification like this or that, but since we are having multiple outputs, like there are multiple variables, we have to check whether this or that or that or that. So we will be using softmax for it and not our sigmoid. So I have made an error. It's activations, not activation. Okay, so once this is done, we have to compile our deep neural network. So till now we have added the layers, but now we have to compile it. So to compile, we are going to use something called model.compile, and this is the most important step in our entire deep neural network building process. because if you see here as compile, this takes in parameters like the optimizer, loss weight, metrics and all. These are like very much necessary. So this is what is going to make the decision on how accurate your model is. So it has to be really good, and it comes just by practice. It's like trial and error. There is no absolute right way to do it or absolute right way to find anything like this is the best optimizer or this is the best loss. So there is nothing like that. It's a matter of trial and error. So for now, I'm going to just tell you whatever worked fine for me. And for optimizer, we are going to use something called the Adam optimizer. So if you want to know more about Adam optimizer, you can click on optimizers and go to Adam. You can see Adam is optimization is a stochastic gradient descent method that is based on adaptive estimation of first order and second order moments. If you want to know more, you can read the entire documentation. So long story short, we are going to use optimizer Adam. And the second thing is loss. And for loss, what we are going to do is we are going to use sparse categorical cross entropy. So this is what we are going to use, and you can read this entire documentation if you want to know more about it. But all I'm going to do is copy this and paste it here because I want to use it. And the last thing is metrics. So metrics is what are the outputs that you want to track. So in my case, I want to track the accuracy. Let's assume that. Okay, so if I run the cell, make sure that it's not giving errors, then our model is compiled. Now we have to train the deep neural network model. To do that, all you have to do is model.fit x train comma y train. So those are the parameters. One is the training images and one is the training labels, and you also have to give epochs. So epochs is like how many number of times the algorithm is checking your data set. So if you give epoch as 1, then it will see your data set once. If you give 3, then it will see it 3 times. Now I have already configured my TensorFlow to use GPU. So if you want to know how to configure TensorFlow to use GPU by default, please let me know in the comments and I will make a video on that. And now I'm going to just run this cell and wait till it finishes all 3 epochs. Just as we expect, the loss has decreased and the accuracy has increased. It is almost 97% or 98%. So that is decent in my opinion. So what we are going to do is like first validate that it's not overfitting. So how do we do that? To do that, you have to create two variables. One is for validate loss and one is for validated accuracy. And you put model.evaluate, and that takes in two parameters. One is the x test and other is the y test. Okay, this is capital T. Okay, it has done the evaluation and you can see that the loss is slightly more than our final epoch and the accuracy is slightly less than our final fitting, like the accuracy of the final fitting of epoch. So that means it's not overfitting. We can be almost sure that it's not overfitting. Now it's just matter of predicting. Okay, let's do the prediction. To do that, I'm going to create a variable called prediction equal to model dot predict. I'm going to put x test inside that, and if I run it, it will take some time. Yes, it's over. Now we can make the prediction. Okay, let me take an index completely random and let me print. Okay, what am I going to print? So what I'm going to print is np dot argmax of prediction inx. So don't worry, I'm going to explain what it is. If you see what is there in prediction, it is just again bunch of arrays, right? But what is the shape of prediction? You can see that it is 10,000 comma 10, which means we have 10,000 training images, and for each image there is an array with 10 elements. So what are those 10 elements? That is what we are going to see now. See, for this index we have these 10 numbers. Now if I want to know what is the maximum of this value, then what I will do is just use the max function and I will know what is the maximum value. So what does the maximum value actually do? So these are the numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are your output. Whatever value is maximum is what your value is. For example, if I do prediction inx dot max, sorry, I'll be getting like 0.99975 is my max. But what is the index of it? So how do I find? I will put np.where prediction inx equal to this value, and you will be able to see that the first value is what, so this will be the first one, so this is what is the maximum among all of them, and its index is 1. So this is like a big command to find out what is the first, what is the index where the maximum value is occurring. Instead of that, you have this nice command which is the np.argmax, and it will return the value, the index value. In our case, that is 1. So let us also verify that it is saying correctly. So I'll put plt.im show x test of inx and plt.show. See, that's 1. And again, let me put a completely random value. So that will be 4. Yes. So let's test for one more value. Yes, it's 3. Okay, so we are getting this. Now we actually don't need this. Yeah, we are getting it. So this is what is the prediction, and this is the value. Now we are able to see that it is okay, correct. But what about this? It also looks like 5 and it also looks like 6, but it is saying that's 5. So let us also print what is the actual label. Y test. Okay, actual is also 5, the prediction is also 5, and the image is also 5. So it is correct and it's working appropriately, just like what we had expected. So now what we are going to do is, like, we are going to save the model. To do that, model.save, let me save it as image model.keras and just run it. Okay, now it's done. Then let us load back the model which we just saved and ensure that it's working fine. So I'm going to put it in a variable called image model is equal to tf.keras.models.load_model, and you just have to put this value or the name. Okay, and run it. Okay, typo. Yes, it is done. Now we can make the prediction. I'm going to put it in a variable called in prediction because it's new, so it's new prediction, and we are going to use the image model. So this is the new model which we just made, and predict x test. Again typo. Okay, it is making the prediction, and let's see whether it is correct or not. So to do that, let's do prediction labels equal to np.argmax, the same stuff which we did already, and put prediction, and we are going to make it as axis equal to 1. Okay, so what it is doing is it is taking the prediction and it is finding the value, and it is saving it in a variable called predict labels. So let's print predict labels. You can see it is just value, the output value for each of the image. If I print the shape, you will be able to see that it has 10,000 values. So for corresponding to each image, it has a value. Okay, now what we are going to do is create the confusion matrix. To create the confusion matrix, there is a very simple way, which is like copy pasting from existing template. So before that, I'm just going to create one small thing, which is the CM. So CM is equal to confusion matrix, and that takes in two parameters. One is y test and the other is predicted labels. Okay, now let me run it. Now we are going to display our confusion matrix. To do that, you just have to do this command. I will put it in the description, you can copy paste. So we are using the function confusion matrix display, which we imported initially, and we are using the confusion matrix as CM. So this CM is our confusion matrix basically. Yeah, we are able to see it, and we are just trying to display it here in a very nice way. And the display, we are saying the np.a range is 10, and that's numpy method. And the display.plot, we are saying cmap, it is blue color. If I plot, we'll be getting this. Actually, I have reversed the blue color, otherwise you'll be getting something like this. Whatever you prefer, I put _r to reverse it. So this is the final confusion matrix. Now there is something which I always like to do whenever you are doing something like the training. If it is very small, save the file, make sure that you are saving, go to kernel and restart kernel and clear outputs of all cells and restart it. Now it's like a fresh template. You can save it in a different name. If you want to make any changes, you can do from here. Now I'm not going to change anything. So let me run it one by one. So I'm going to run this cell. Everything is imported. Now let's import the data. We have loaded it, and let's show one image. Maybe this time we can show something else. Okay, then I can show this. Okay, we have created our deep neural network model. Now we are going to compile it. Yes, the compilation is done. Now we are going to fit it. Let's wait till it is over. It will be quick because I'm using my GPU. Okay, now let's do our validation losses. Yep, it is done. Now let's make the prediction. Okay, it is showing correctly. Now let me anything else. Yes, it is correct, and we can do this. Yeah, it is correct. Now we can save the model, load the model, and predict it. Again, predict the labels, and then plot the confusion matrix. So I hope you learned how to do the image classification. Now you can do the same thing with any other data set if you have, and you can try to explore it. And if you change the final activation as a sigmoid, then you can do classification like cat or dog, or if you want to do pizza or not pizza. So you can download any of the data set and you can try to do it. If you enjoyed the video, consider dropping a like, consider subscribing to the channel. If you want more tutorials, please comment down what you want, and thanks for watching. See you in another video.